Good morning, everybody. Today you have Mrs. Grottle as your sub, and I decided to go ahead and make you guys some recordings for your notes since I'm not here and Mrs. Hurt's not here, and Mrs. Grottle is very good, but unfortunately there's not a whole lot of people that have the calculus background. So we're going to go ahead and talk about a couple things here with your notes for today, and this will be happening all this week. So first thing I need you to do is look at your homework key from Friday. It is attached on Classroom. I have worked out all those problems for you. Remember, there's lots of different definitions of a limit. You can use the A way, the T way. I use the delta X way throughout this homework, so please be aware of that. You may not have used the definition that I used, but at least you can see the answer, and then you can hopefully go through my work and see what I did. So I'm going to go ahead and pause for a minute here while you guys go ahead and take a look at that homework key. You can pause the video and then pick it back up when you're ready. Okay, so today, Mrs. Grottle should have passed out to you a worksheet. There should be two parts to that worksheet. You have 1 through 10 on the top, and you have 1 through 6 on the bottom. So let's take a look at the top, and we'll go ahead and go through this. And I'm just going to put the answers up here, and then we'll go ahead and work it out. I'm not going to do much explaining. I'm just going to show you my work. So here we go. Number 1, you can simply plug that in. No domain restrictions. And there's your answer. Now, as we're going through this, I highly suggest that you guys try this worksheet on your own. And then when you're done, you go back and you check your answers. Number 2 here, we do have a domain restriction. So I'm going to go ahead and factor. Cancel. And now if I plug in that 3, I get that. Number 3, we can use one of our special trig identity limits if I factor out a 7. And then we have this portion right here. That is 0. So effectively, we have that for a limit of that. Number 4, please note that this is simpler than it looks. We're approaching pi over 2, so I can go ahead and just plug in pi over 2. So we have that. And then if you go ahead and evaluate, 5 over 2 is 2.5. So that would be the same as the sign of just pi halves. And then we will keep this down here. The sign at pi halves, that's 90 degrees. So the sign is 1. And then if you multiply it by the reciprocal, you get the final answer of that. Okay, number 5, you need to do some substitution here. We are going to use our sign identity. So I'm going to say that. And I also will need to solve for x while I'm at it, which would be that. So now I have the limit as x approaches 0 of 8x, which is still 0. So now my new limit will be the limit as y approaches 0. and make your substitution. So we have this portion right here is 1. So effectively, we have this. When you multiply by the reciprocal, you get a final answer of that. Number 6, looks like we're going to have to multiply by a conjugate. So that's what multiplying by the conjugate will look like. When we multiply, we get something that looks like this. This will end up being that up top, which means these will cancel. And now I'm ready to plug in my 6. If I plug in my 6 to this, I'll get a 1 on top. And then, let's see, that'll be the square root of 9 plus 3. That'll be 1/6. All right, we've got a piecewise function here. Please notice that we are approaching 7, which is a critical number for this piecewise function. If you look at this piecewise function, it is the hiccup function. This piece is linear. So everywhere that x is not 7, it will be linear. And then when x is 7, we have a single point. So remember how we talked about this. The limit is what it converges on. So we do not want the hiccup, we want the linear function. So if you plug in 7 to the linear function, you get your answer of 23. All right, let's take a look here. We got some trig going on. This doesn't quite look like one of those identities, the cosine or the sine identities. So I think what I'm going to do is I'm going to change this into sines and cosines and see what happens. Okay, so now if I multiply by the reciprocal, these will cancel. And I'm left with, and now if I plug in 0, cos of 0 is 1, I get a final answer of that. All right, number 9. I wonder if I can just plug it in. Well, secant is the inverse of cosine in the bottom. So if I put a 0 in there, I'm going to get a 0 in the bottom. So that's going to be a domain error. So I'm going to have to do some finagling here. What I think that I'm going to do is I'm going to try and I'm going to change the top to sines and cosines and see what happens. Get a common denominator. Looks like that. Multiply by the reciprocal. And now it looks like that. Well, I think I should be able to make some substitutions here. The question is, what are they? Well, we have this identity. So if I solve for, if I move the 1 over and move the sign over, I now have that. The Question is that going to help me? I don't think that it is. I don't think that it is. Let's see here. What else can I do? Well, you know what we can do? Let's go back to the beginning. And instead of just changing the top to sines and cosines, let's change both the top and the bottom to sines and cosines and see what happens. Oops. Which would make it look like this. Okay, well, let's multiply everything by cos x over cos x to get rid of that fraction within a fraction. So there's my numerator. And here's my denominator. And now I think we're in business. Factor this by perfect squares. They cancel. Plug in your 0, and you get a final answer of 2. Okay, one more in the top section here. Well, it kind of looks like one of our identities, but not quite. So I think what I'm going to do is multiply by the conjugate of what's up top, which would look like this. So now, when I multiply that through, it looks like that. And up top, I can do that substitution of my Pythagorean identity. Remember, we have this. So up top, I can just make that sine of 5x, sine squared of 5x. And you can see that that's going to help me cancel in the denominator. And now I can go ahead and plug in. And I get a final answer of 0. Okay, so that's the top section. The bottom section, you are asked to graph these things. Okay, so the first one looks rational, but it looks like it's going to have a domain error. So what I would do is I would factor it. And basically what you're going to be left with when you factor is a linear function. So this thing should be linear, and it should have a hole where x is 3. And the coordinate of that hole would be at 3, 5. Number 2, that's a parabola. Okay, remember, find the vertex and make that parabola. Number 3 is a square root function. So basically, you have to figure out where is this thing going to be 0. So this is going to be 0 when it's 3. You cannot plug in any numbers that are less than 3. So you're only going to plug in numbers that are greater than 3. And you should get a square root function that looks something like that when all is said and done. Number 4, piecewise function. You should have 2 pieces. They are both linear. Remember, this one gets a closed circle, and this one gets an open circle. 2 linear pieces. Number 5 is a rational function. So the only number that you cannot plug in is 0, which means there's going to be an asymptote there. Okay, when you plug in these numbers, make a table, you should get a graph that looks something like this. And again, you should be doing this on graph paper. You can make your own, or there's some on the cart over at the side of the room. And number 6, very similar. X cannot be 0, so that means there's going to be an asymptote there. When you graph this thing, pick some numbers, plug them in, make a table. Because this thing is squared, you're only going to get positive y values, so it should look something like that. Okay, so that is Monday, November 6th, and you were to work on this during class, and then whatever you did not get done was homework. So that is your first day of this week. Thanks.